Good evening, everyone. Thank you so much, President Miller, for the wonderful introduction. And thank you so much for the invitation to come share with you a little bit about my work and also my story of how I came to Olin. So as President Miller mentioned, I have a background in aerospace and systems engineering, and I've also spent close to 10 years in the engineering education research community. So when I talk about my work, I typically talk about my teaching and my research and my work with other educators at other institutions as working at the intersection of human-centered design, systems engineering, and engineering education. So thinking about all of that work and how it comes together in this intersection, one of the things I was so excited about coming to Olin for was to get to work with other people who cross disciplinary boundaries every day. And one of the other reasons I was very excited to come to Olin was our shared passion about how we think about supporting an undergraduate engineering education experience for Olin students and for students at other institutions. So really thinking about how we are developing the next generation of innovators who are going to go off and positively impact the world. And what's even more exciting there is that all of the members of the Olin community, the faculty, the students, the staff, the alumni, the board, the President's Council, and so on, all of the members bring their own perspectives, their own passions to answering this question. And so we're each working on our own little things as part of a bigger ensemble. And it's just been very exciting to find out things I can collaborate with others on, but also work that I can do to support this larger mission. So tonight, I'm going to share with you a little bit about my story and a little bit about some of my work as it works towards this larger, broader question. So let's start with a sub-question that we're going to be talking about for the rest of the evening. So how might we learn from engineering practice to design an engineering education that prepares students to become these innovators that positively impact the world? So when I give you this question, it tells you a little bit about me right off the bat. So the first thing it tells you is that I have a very design perspective. When I think about my courses, my learning activities, my assessments, I look at education as designing an educational experience for my students. I even consider myself a learner-centered designer, not just a human-centered designer. And the other thing this tells you is it kind of says something about engineering practice is important to her. Why does she care about what practicing engineers are doing? So to tell you why, I'm going to take you back a little bit, all the way to when I was a little girl, and I was taken to see a movie. But if you ask my mother, it was more that I was dragged to see this movie. I really didn't want to go. Now, this movie was based on a true story of an important event in the space program. In April of 1970, Apollo 13 launched from Cape Canaveral. 2 days into their mission to the moon, one of the oxygen tanks in the service module ruptured, and the second was failing. So rather than focusing on getting these astronauts to the moon to do their specific experiments and projects, all of not only the astronauts, but the engineers, the mathematicians, the scientists, the human computers were all working together to try to bring these astronauts home safely. This was a pretty inspirational story that I had never heard really before. It was very exciting. But what's interesting about it is that it wasn't just the story, the bigger story, that was inspiring. It was this moment in the movie, but also in the real life story, that really changed my mind about what I wanted to do, what I wanted to major in, where I wanted to go to college. So to tell it best, I'm going to share an excerpt with you from one of the flight directors of Apollo 13. He says, "Engineering gave us a status report indicating that they were close to a solution on another problem. The crew's breathing was slowly poisoning the cabin atmosphere with carbon dioxide. We had run out of cylindrical air scrubbers used in the lunar module, and engineering was testing an adapter for the square command module canister that was being fabricated from cardboard, a plastic bag, a sock, and a hose from one of the crew's pressure suits. The device was all held together by duct tape, a commodity which, fortunately, was always carried in the spacecraft." This scene was so inspiring that I put aside my thoughts of archaeology, of pure mathematics, of marine biology, to pursue a degree in aerospace engineering. I wanted to be one of these engineers. Now, what's interesting, years later, putting my engineering education research hat on for a second, is that what happened at this moment to this young girl was she made her first characterization of what it meant to be an engineer and what engineering was in her mind, right? And so what I saw, looking back, what I defined, my first definition was, engineering was about collaborating to creatively solve open-ended problems filled with uncertainty and constraints. That was my view. And the more I spent over the next few years digging into the space program, learning more about it, I really began to see that these individuals were creating the pathways to this brand new discipline. They were coming up with the roles, they were coming up with the responsibilities on the fly. Their degrees were not necessarily in aerospace when they got there. And they were creating things every day, working against constraints to solve almost impossible problems, what others would characterize as impossible. I wanted to be part of this world. Now, mind you, I recognize they weren't perfect. They made a lot of mistakes, and they weren't just technical ones. There were a lot of risks when you were sending people to the moon, putting people in space. There are lives at stake. And I want to recognize that as we move forward. Now, one thing here, though, is no matter what those risks, I wanted to pursue a career in aerospace engineering. So this leads me back to that question from before. And if I put my childhood self up here and said, well, how would we change this question? She might say, it would read, how might we learn from engineering practice to design an engineering education that prepares students to innovate, collaborate, and solve impossible challenges? So I ended up deciding to go pursue a degree in aerospace engineering. I had a very great experience in my undergraduate program. I met a lot of wonderful people, and I learned a lot. But again, kind of putting my engineering education research hat on for a moment, if I abstract what I learned from that experience, what that experience told me about what being an engineer was, it wasn't exactly what I expected. So sitting in those classrooms, I was tasked, and this one including, I was tasked with memorizing equations, using a very prescriptive approach to solve problems. And I'd better make sure my math was right. And above all that is I ended up spending more time sitting alone working on work than collaborating with others. There's that scene that I won't forget of sitting in the gym during finals week with hundreds of other students at my own little desk with my white paper with all the exams, my pencil, and maybe a calculator. That didn't really resemble what we talked about before with these engineers all working together with cardboard and plastic bag and a sock. But there's something about this, and what it speaks to is that emphasis on risks that I was mentioning before. What it seemed to have taken, what seemed to be abstracted from the practicing engineers were, this engineering work is dangerous, it's risky, and we have to pay attention to that. We need to do it right. So let's come back to this question. So with this in mind, when I was pursuing a graduate degree, I thought, well, I understand those risks, but I want to push on this more. I want to keep asking questions about what we can learn from engineering practice that's still preparing students not only for that high-risk environment, but also to solve these impossible challenges. And so that brings me to what I'm doing here. So over the last 2 years, I have been working with a group of amazing Olin students on problems in this area. So what we did at the start of 3 of the students, it was their second semester here at Olin, I asked them, I said, I'm trying to look at this type of a question, but I want to know what you're interested in. What do you want to know about engineers in practice? And let's do a research project on it. So they spent weeks reading papers, iterating on research questions, and what they came to was this idea of how can we better prepare engineering students for the communication and decision-making that take place in cross-disciplinary design environments. That's what they wanted to understand. And so what we did is we designed a study. We went to 3 organizations, 1 small software company, 1 medium-sized consumer electronics company, and a large vehicle design firm. And we interviewed and did observations of design team meetings to understand what those practicing engineers were doing in terms of communicating across disciplines, what artifacts were they using in particular. So the students were really interested in how is a PowerPoint presentation supporting communication across disciplines? How is a chart? How is a prototype? How is that helping decisions being made in this process? So we spent a summer deep diving into this through a field study, and we have been working for the last 1.5 years on analyzing this this data. Now, there are lots of different results that I would love to tell you about, including where the project is going now, but I'll save some of that for dinner conversation. So I'm going to focus on one result and share with you how this comes back to that larger question that we talked about at the beginning. So one of our results was based on this idea of that we saw at all three of the companies, small, medium, and large, where they were basically handed by someone in upper administration an externally created artifact that was supposed to support decision-making or communication or process. Here's this artifact, go use it. So this could be something like Scrum, Lean. It could be something like another process management. It could be something as simple as Trello or Jira, if you've heard of those. They were handed these artifacts to use in their groups. Now, what was interesting is in all three of these cases, this process occurred in each one, but very differently. So these groups would take this product and go, okay, how are we going to use this? So they try using it right away. This is how you use it. This is what we're told to do. Let's use this product, this artifact. And then slowly over time, they would come to realize that it wasn't really working the way they thought. And so they started adapting it and changing it based on their culture of their company, the product they were designing, the amount of people in their group, and if they were working across groups or they were working within a group. And what resulted from this process of adoption and adaptation was this very impactful artifact. And what was very cool is we could actually see at the end these artifacts coming together that these groups loved using, all coming from very similar externally created artifacts. But the end product was very different and very specific to each corporation and group. So I have this result. Now what? So one of the things I've been doing is thinking about if I do these studies of engineering practice and working with my students, we get these really interesting insights about practicing engineers and designers. But how do I get this to the classroom? How do I help think about how we're better preparing students to go off into these cross-disciplinary design environments? So I can rephrase my question based on this, is how might we learn from engineering practice to design an engineering education that prepares students for the collaborative design environment they will experience after graduation? So what I have come up with and been working on and iterating on over the last several years with students as well as Olin faculty is this idea of moving from insights to what we're calling educational design elements. And this is actively being discussed, actually, at a meeting this Wednesday. So what's very cool about this idea is instead of saying, okay, I learned something from industry, I'm going to turn it into a handout and hand it to you to use in your classroom. Well, that's actually kind of going against the insight entirely that you're going to take this artifact and use it as is. So what this is saying instead is, why not come up with these particular design elements, almost like principles that are important to the design, but that can be context agnostic. So you can choose to take one of them and use it in your course, but it doesn't matter what your course is because you can apply it there. So let me give you an example from this project. So one is this idea of just try it. So fully committing to engaging with a new tool or approach before giving up or modifying it. So what I mean by this is in a class, if I'm going to present something to my students and I really want them to try it, I might frame the discussion around, okay, you're going to try this tool. Humor me. Just try it for today and tomorrow, and then we'll talk about how it goes. Don't change it, just try it as is, and let's work on it. And so that's something I can do in a quantitative engineering analysis course, in a human-centered design course. I can get them to try to fully commit for at least a little while. And a second design element that comes from this insight in particular is this idea of the freedom to bend it or break it. So it's not just about that initial commitment to something before modifying it, but it's that once you've tried it, you've really tried it, taking some ownership over it and feeling like you can bend that approach, change that handout, move that framework around, and modify it for whatever application you're working on, adapt it. So with these two design elements now, it doesn't matter what course I'm teaching, I can think about how to bring these into my classroom. So let me give you two examples of that. So here we have, as I said, the insights and educational design elements and how I'm going to prototype them in my classroom. So the first is with our senior design students. So what's very interesting is in the second year at Olin, as many of you know, we have our user-centered design course, UOCD. In this course, students are learning this process that goes from identifying a user group all the way through exploring the user group coming up with design principles and insights, ideating, co-designing, and finally coming up with a proposal of a product that could help that user group. It's this process that the Olin students get to know very well for their time at Olin. When they get to senior design, what's very interesting is no matter what the project, if there's a human component in it, there's a tendency to want to replicate UOCD as is. And UOCD is an entire semester long, so in a year-long scope project, all of a sudden we have a semester of UOCD part 2 and then the rest of their scope project. So that doesn't always work for every project. Some cases, yes, but not every one. And so what we wanted to do this year is we wanted to run a workshop that had students remember that artifact, that process from before, and then own it and bend it and break it. And so we started going through, well, what was the process? And then helping them, scaffolding this idea of how would you adapt this process to your project? Could you rearrange the steps? Would that work? Could you have 2 user groups, not just one? So we asked lots of questions to the students around this. And what was really cool at the end, when we asked for feedback, is one of the sticky notes that a student left at the board was, thank you for giving us permission to break UOCD. So there's something about this. So another example, though, let's get outside of the classroom, and let's talk about interacting with other faculty and educators. So each year, as many of you know, we run a summer institute that focuses on student-centered learning experiences and the design of those. We start the week off providing frameworks and an introduction to important educational constructs like intrinsic motivation, different pedagogical approaches like project-based learning, and the people there, all the educators who are there on teams to work on a particular project for their institution. So this year, one of the things we wanted to work on was the development and use of personas. So this has been done in the past where people have come and they've interviewed students from their institution and they're creating something called a persona, which is a characterization of sorts that can tell you a little bit about maybe more than one student at your institution. And you can use it as a design tool. So to not go too far into that, what we've seen in the past is personas are introduced, but they don't necessarily make it through the whole week. The educators use them at the beginning, but then they discard them. And so this year we wanted to try something different. What if we worked at the beginning on really having them deep dive into personas, not only coming up with their own, but actually playing with Olin personas, so that idea of committing to it, really trying, and then we give them more ownership as the week goes on. So what was very cool is the way we did product framing, we kept bringing up personas throughout the week. And at the end of the week, almost, I think 95% of the teams, these institutional teams, had personas in their final presentation. But what was even cooler was that there were faculty personas now. There were institutional personas. They had taken this framework and evolved it to fit their project and adapt it that way. And so this is another example that's not in the classroom necessarily of saying, okay, here are some interesting educational design elements. How might I use them to support an overall learning in the process? So thinking back to how I started this conversation around trying to understand and learn from engineering practice, this is a process that I've come up with and been modifying over the past few years, starting with studies of engineering practice, coming up with insights from those studies and specific educational design elements, prototyping those with students and educators, reflecting on what worked and didn't, and coming up with new questions based on those experiences, and then eventually studies of educational practice. So to give you an example, my students were continuing with our work on the studies of engineering practice, and will be moving into studies of educational practice over the next couple of years. So with that in mind, and this question at the center, what I like about it is I can fill in the rest depending upon what I'm interested in learning more about, what the students are interested in, what makes sense for the time or is relevant. So with that, I want to leave you with a similar question. So what might we learn from engineering practice? What engineers are doing on a day-to-day, what challenges they're facing, what successes they're having, what new problems are coming down the line, to design an engineering education for students inside and outside of Olin, so collaborating with those educators, not just from here, that prepares students to innovate, collaborate, and approach these impossible problems. So thank you for your time.